Hello everyone, welcome back to another video. In this video, we are going to be doing exercise 4Q, where it asks us to plot the graph of f of x when we're given f prime of x. Okay, when you get something like this, the first thing you want to do is find where f of f prime is equal to 0. These x-intercepts are basically where it's the turning points of f of x, or the stationary point, so I'm just going to go ahead and mark. That's not doing what I wanted to do. And mark each of these individual spots. I guess I'll consider that a spot for now. Okay. Next, I need to check if f prime is above or below the x-axis. When it's above the x-axis, that means that f of x is increasing. So that means I can go ahead and start over here and draw, say, something that looks like this. However, we're now at the stationary points, so that means from now on it's going to start decreasing, so that's the highest that peak's going to go, or the local maximum, I guess. Now that f prime of x is in the negative, y value place, f of x starts to decrease. And it's going to, no, that's a bad way to put it. And it's going to continue to decrease until we get to our next stationary point where it becomes positive again. I'm going to kind of chart it out like this. So boom, decrease, and right our next stationary point. Now that f prime of x is positive, we're just going to go ahead and label that f of x. This function is going to start increasing again, and you can't really map these out perfectly. It's just kind of estimation since we're not given much. So now we're going to keep on going till the next stationary point, and that lands us at around 3, that is. That's not that important since we're just factoring the function. And now look at that. We're dropping back down to negative on f prime. So this function, once again, decreases. And it looks like we're going to have one more stationary point right here if that's hitting 0. So yeah, that's how f of x should look like. And let's go ahead and go to B. I have these set up a bit weird, so just give me a second. That's not what I wanted to do. Hold up. Oh, great. I don't know how to grab this. Oh, there we go. Okay. I'm going to separate these a bit better so I don't have to worry about that again. Wow, that is laggy. Okay. B seems a bit more simpler. So we know this is f prime of x. This purple line here. I guess let me change the colors for them so more reasonable. Ignore any bells you hear. That's f prime of x. F of x is going to be in black. Okay. F prime of x starts off positive already. In that case, we know it's going to be, or f of x is just going to be starting off increasing. And once again, it's kind of hard to tell where it's going to start off increasing here. Just like generalize it a bit. Don't go too high up. Don't go all the way down here. It's more important that you're able to graph, the turning points and everything. Oh yeah, let's go ahead and first chart out where each of the y values are equal to 0. Those are going to be our stationary points. It looks like we have it at 0.5, 2, and around 3. Okay, and that all disappeared. And 3. So going up, and stationary point number 1. Now that we're here, we go down. We're going to go down. And now we're at stationary point number 2. So positive. Let me label it out like this. Bless me, God. Okay. Negative. And now that we're at the next turning point where I'm about to sneeze again. Okay, now that f prime is positive, f of x is going to start increasing. until we get here. And then it's going to decrease once more. I'm going to draw this one a bit higher just to kind of show that decrease. And we stop around here. Hey, and that's a relatively similar graph to what f of x should be. On to C. Let me enlarge this one a bit. This is 1C, by the way. That did not work in my favor whatsoever. Okay, there we go. Again, what the heck? Why is it doing that? Stay. Okay. Good. Okay. This one's a bit ugly, but it should be fine. Let's go ahead and then identify when f prime. I'm not going to switch colors anymore. Let's go ahead and identify when f prime is 0. We have 1 stationary point, 2, 3. This is probably like some sine function or something. 5 stationary points. And let's go ahead and list when it's negative. So this region's negative, positive, negative, and positive. Okay, when f prime is negative, that means f of x is... Wait, what? Wait. Okay. Something new is getting added. Okay, I was right though. We're still right. When f of x, I'm going to start here. Oh my god, you gotta be kidding me. Okay. So f of x is going to be positive. However, we're going to go along with the function where it's decreasing. Wait, hold on, I'm like losing my train of thought right now. Oh my god, okay, yeah, I'm losing my train of thought. Okay, this function is decreasing. Decreasing. I don't know what I'm saying. Lost my train of thought. F of x is decreasing since this is in the negative region. We're going to go down. But now, f of x is going to come back up since this function is also increasing. Now we're going to go back down again since we're back in the negatives with f prime. And now that f prime is in the positive, f of x is going to be increasing. Not there, but here. And that's where we stop. Okay, I'm sorry. That was a little confusing. But yeah, that's basically how it is. We'll explain D a bit better. Okay. Let's go ahead and once more, remember, actually I'm going to change colors for this one. Okay, we have f prime. Identify when f prime is equal to 0. Those are going to be our stationary points for f of x, or our turning points. So 0 at 0, around 3, around 6, and around like 9.5. Okay. Positive 0 here, actually. But we're going to keep that as positive, negative, positive, positive, and negative. Okay. We're going to start off with f of x increasing. Now that it's hit the stationary point, it's going to kind of like twirl around for a second, but it's still increasing, mind you, until it gets around here. And now that we're here, it's going to start decreasing along with f prime, since f prime is negative. f of x is going to be decreasing till around here, and then increasing once more, and decreasing. And this is f of x. I didn't really explain it, but the reason why is this all works is f prime is just the slope of f of x at a certain point. So if our slope is negative, then our function is decreasing. I should have said that. Okay, on to number 2. Number 2 is a bit different in the sense that we're going to have to make two graphs now. It gives us f double prime, and it asks us to make the graph of f prime and f of x. Let me go ahead and move. Okay, that didn't work for me. Move him over here. This is 2a, don't forget. This one's going to be big. Okay, so we have f double prime of x. Okay. Likewise, I don't know what notification I just got. I'm going to do dark blue for f of x. Okay, likewise with f of x, f double prime of x is the, the next derivative of f of x, which is the slope of it. So we can apply the same thing we were applying earlier. So positive here, that means function is increasing. Oh wait, let me first mark out where f double prime equals 0, so we don't get confused later on. Okay. Positive, so f prime of x is increasing. We hit our we hit our turning point / inflection point. I forgot which one was which. Now we are decreasing. That was a bad decreasing graph. Now we are decreasing till we hit 0. And now that we're at 0, we start increasing again. And we just increase for the rest of the graph. Boing. And that is f prime of x. Okay, switching to black or red now. Switching to red now, we're going to do the same exact thing we just did earlier. Negative over here. This means that f prime is... I might just be getting this wrong, by the way. Let me mention that. F prime is negative over here. This means that our graph is going to start somewhere along the lines of decreasing, but not for long. Oh, wow, that's so ugly. No, we'll draw like that, I guess. Decreasing here, and then you have it increasing. And it's going to be kind of still here, but then it's just going to go back to increasing. Okay, and that should be f of x to an extent. Sorry, this is confusing. I never really understood this subject much. I know how to somewhat graph it out. I have no clue if I'm graphing it out right or wrong. Okay, on to B. That's the best attempt that I could get at. Consult the teacher about this. Being able to graph them out isn't as important as just being able to recognize inflection points, turning points, and slopes. That should be your biggest concern, definitely by far. Please get out of here. Okay. Let's go ahead and mark this as f double prime of x. Okay. Find where... Am I losing it right now? Okay, find where f double prime equals 0. gonna have it right here, 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 and maybe over here. Yep, over here. And now we're gonna switch to blue to map out f prime of x. This area down here is negative, so f prime of x is going to be a decreasing function until we get to here, and then it's gonna start increasing again, and then decreasing again. Now we're positive on f prime, so now we're gonna start increasing again. And once we hit this point, the inflection point, we start decreasing. And that's f prime of x. Okay, on to f of x. We're positive for a little, but it's really just a little from what we graphed out. So now we're gonna decrease, and then we're gonna, oh, that's the line. Decrease. Now once we hit around the same point, we're gonna start our increase, but then we're gonna hit the next turning point. Oh wait, sorry, I didn't graph that out right. This is still gonna go negative, and once this becomes positive, then we start increasing, and now it's negative again over here. So we start decreasing once more for a while until we hit around our next turning point, and we just start increasing. Okay, there you go. Those should be the answers. Once again, I can't with these graphs. They're so weird, and I don't like graphing them out just because there's so many ways I guess you can do them, so many assumptions you're making too. It's weird. Just understand that the slope of, the derivative is just the slope of the original function. So when the derivative is negative, that means your original function is decreasing, because when you have a negative slope, you are decreasing. Boom. All right, have a good one, and I hope this helped. It probably didn't much.